Right, so we're going to start out by looking at the second part of 2.2, which is really very short, basically about graphing and finding what's called a break-even point for a company. Like if you know their profits and you know how much their expenses were, you can kind of find like, all right, maybe they need to produce a certain amount of product to break even. And then after that point, they start making profit. Okay? So that's what we're going to start out with. So this particular example is going to be about a company that has fixed costs and variable costs. All right? Maybe the fixed cost is the salary for the employees. Okay? That doesn't change. The variable costs, I think this is going to be about a t-shirt company. The variable cost would be how many t-shirts they make. Right? Because the more t-shirts they make, maybe it costs them like $1 per shirt to buy it and then use the ink. So that cost changes depending on how many shirts they print, right? But salaries for the employees stay the same. So that'd be a fixed cost. So this company has a fixed cost of $200,000 and a variable cost of $1.50 per shirt. Okay, so that cost, the total can change depending on how many shirts they make. And each shirt sells for $4. So we want to make sure we understand the difference between cost, revenue, and profit. So cost is how much money the company spends to do what they do. Revenue is how much money they bring in. Profit is the difference between the two. If you take cost, or if you take your revenue minus your cost, if it comes out positive, then you made profit. If it comes out negative, you didn't. All right. So, first thing we want to do is find a complete graph of this problem situation. So we're going to make up a couple equations. And the two equations we're going to make up are total cost and revenue. And both are going to be a function of how many shirts we make. Because how many shirts you make will affect both the revenue and the cost for the company. All right, well, first thing I need a variable. Okay. For shirts, you can use an S, but sometimes S looks like 5, so let's just use X. So just put an X under shirts. All right, so let's start with a formula for C of X. Cost as a function of how many shirts we make. All right. How many costs are there for the total that we have to deal with? Different types of costs. Yep. Yeah, there's two. There's the fixed and the variable. So let's start with the fixed cost. What was the fixed cost for this company? Was it 200,000? So I'm going to put that right here. That's kind of like it's going to be like a y-intercept. And now the variable costs. It's $1.50 per shirt. So how would you represent the variable cost? What would be the expression? Yeah, Zach. Wait a minute, no. Yes.
Would be 2.5x because the cost of buying a shirt minus. Oh no, the cost would be minus 1.5, and then the 4 would be yet money from selling a shirt.
Don't worry about the 4 yet. That's going to be part of the revenue equation. So just how much does it cost to make a shirt?
Just $1.50.
That's it. So the cost is just $1.50x. If you plug in how many shirts they make, it will tell you how much cost they had. All right. So there's their cost. And what would be the formula for revenue? So revenue is just how much money they bring in. Don't worry about profit. That's different. Yep.
4x.
4x. Yep. So that's the money they take in from selling the shirt. $4 per shirt. Yes, that's not all profit, but we're not worried about that yet. Okay. Any questions on those two equations? All right, so let's graph them. And so we go. All right, first of all, is a standard window going to work here? No, we're way, way above that. So for my window, well, X is how many shirts we make. Okay, there's no upper limit on that. So let's just maybe go like, I don't know, let's try 10,000 shirts. Okay. What you really don't need to worry about is negatives. You're not going to have a negative amount of shirts. Y max, that equation has a y-intercept of 200,000 and it only goes up from there. So maybe let's set the y max at, I don't know, 250,000. I'm not sure if that's going to be good. And then the cost and revenue, neither one of those are negative. You don't have negative costs and you don't have negative revenue. Okay, let's type it in. 1.5x plus 200,000 and 4x. When I hit graph, I'll know pretty quick if this is a good window. Not quite. Okay, because I'm looking for something special between these two graphs. What do you think I'm looking for eventually? I'm looking for where they cross. So I can see that the red line is going to catch up eventually. That's their revenue. And eventually it'll come up to the costs. But we're going to have to set x, I don't know, let's try like 80,000. But then the costs are probably going to go off the screen at this point, so let's try 350,000. Okay, so I think my y max is good, but I set my x a lot higher than I needed to. We could probably set it at like 40,000. And then it wouldn't look so squished. I think that'll probably, okay, well, maybe not.
So is that 800,000?
I think you said, yeah, I said at 800,000.
Oh, I said at 800,000, okay.
Yeah. Mine's
So-
at 80,000 and you can just barely see it, so.
So, okay,
Mine's
yeah.
95,000, I can see it.
So 90,000 will probably be perfect, that's good. All right, so yeah, 800,000 was okay, but it was kind of squished. All right, so there's a complete graph, and as far as what you would write down, we just take the window and copy that over. That was 0. Okay, and there's other options, but that's a good window, and I think that's all they wanted. Find complete graphs. Yep.
So that'll be your answer?
Yep. You'd write down the x max, these 4 values right here. X max, x min, y max, y min. Okay, so the break-even point, which is really the whole thing we're doing in this problem, is when the cost and the revenue are the same. So for a graph, you guys already said it, but what are you looking for if you have a graph of cost and revenue? The intersection, yep, where they cross. So let's take the same problem from example 1, and we'll find the number of shirts that this company has to make in order to break even. So let's start algebraically. So remember, break-even point. Cost, revenue are the same. Okay, so basically that's where cost equals revenue. That's how we figure it out. So now I just need my 2 formulas. The cost one, I think, was 1.5x plus 200,000. And what was the revenue one? 4x. So you get a very, very simple algebra 1 equation to solve. So 200,000 equals 2.5x. And divide 200,000 by 2.5. Divided by 2.5 gives me 80,000. So I solved that probably faster algebraically than it would be on the calculator. Okay. I think it took us longer to figure out the window than it did to do all of that. Okay. But that's how you do it algebraically. So 80,000, that was shirts. Now, to do it graphically, you'd have to do everything we already did. Type it in, get a window. And now, what do I press to see where these cross?
Second calc.
Second calc, 5. 5. So, pick a point on the blue, the red. The guess doesn't matter because there's only one point where they cross. So no matter where you put the guess, it'll find it. Let's see if I can... Oh, I have to do it twice. Still figuring it out. Okay, so the intersection, right there, 80,000 shirts. Now, looking at that graph, it tells you something else. What is the cost for this company to produce 80,000 shirts? 320,000. What is the revenue if they produce 80,000 shirts? How much? The revenue. So the cost is 320,000.
320,000.
The revenue is also 320,000. This is the break-even point. It's when the cost and the revenue are the same. So now every shirt they make after 80,000, now they're making profit. Okay? Before that, they were still kind of in the hole. Maybe the $200,000, if it was a business, that could be like the startup cost. So it takes them a while to start making money. Any questions on that? Okay, so from that section, the homework for that part is like 3 problems. It's like find a cost and revenue equation, graph it, tell me where that goes. So most of the homework is going to be from this. Okay, so we're going to look at solving linear and quadratic equations algebraically. Probably the hardest thing we're going to do in this section is we're going to derive the quadratic formula. So you've probably been given it, negative b, plus or minus, all that stuff. But there's a reason why it's a negative b, why there's a square root, why there's a 4ac. Like all that comes from something, and we're going to see where it comes from. All right, but before we get to quadratics, we're just going to start off with basic equations. Okay, so remember, equation is any statement that has an equality or an equal sign between 2 expressions. If you use x for your variable, sometimes people say write an equation in x, or like that's what I did here. This is cost as a function of x, this is revenue as a function of x. Okay, if you used L for your variable, you could write an equation in L. It just means it's L is the variable, that's all. So when we solve an equation, that means to find the values of x that make it true. Right? So for linear equations, not really a ton of possibilities. Think about if you draw 2 lines, all the different ways they could cross. They could be parallel, they could cross in one spot, or they could be the same line right on top of each other. Right? When you start looking at like lines and other shapes, like lines and parabolas, then you can get other things that happen. Like sometimes they cross in 2 spots. But lines are the simplest case. So remember, an identity is a special kind of equation that is always true. Right? It's an equation that when you solve it, you figure out that, wait a minute, x could be anything, and this equation always works. That's an example of an identity. So somebody in Algebra 1 might look at that quickly and they start doing it out and they're like, okay, I'll distribute on the right equals 3x plus 3 minus 1, and then they'll combine like terms and you get 3x plus 2 on the left, 3x plus 2 on the right. So you have exactly the same thing on both sides of the equal sign. That's when you know you have an identity. Any questions on that? So again, some of it I'm going through kind of quick because this I mean, solve an equation. It's really Algebra 1 stuff. So a conditional equation is an equation that can be true. It's not an identity that's always true. A conditional equation can be true if you pick the right value for x, like 5 in this case. Okay, so certain values value or values, make it true. So, once you have an answer, if you want to check if it's a solution, you plug it back in. Okay. Been doing that for years now. So, all I want you to do with this one is verify that the number I'm giving you is a solution. That'd be a little hard to solve by hand right now. Eventually, you'll know how to solve cubics, at least some. But in order to check that -2 is a solution, what am I going to do? Plug it back in for x. And when I do it, what am I hoping to get on the left side? 0. If I get 0, then -2 is a solution. Okay? So -2 cubed. Be careful when you plug it in, -2. Some people mess that part up. Plus 6. I'm going to put a question mark there because that's what I'm checking. I don't know if it's true. Okay, how about Derek? What's -2 cubed?
Negative x. I mean -8.
Yep, -8. And Skyla, what's -2?
Plus 2 to -6.
So +2, and then what'd you say?
I would do -6.
Yep, so we'll do that in a second. So now -8 plus 2 is -6. -6 plus 6, we're good. So -2 is a solution. If you plugged in a number on the left and got anything other than 0 in this particular problem, it would have been no solution. So any questions on how you check if a number is a solution? Okay, I'm not going to ask you in Algebra 1, I ask people to check their answer on the test, and that's part of what I grade. If you want to check your answer to see, you can always check it yourself. Okay. All right, so that's the format of a linear equation in x, using x as the variable. Some people write mx plus b, ax plus b, it doesn't really matter. What's important is that a and b can be any value you want, any real number, except a can't be 0. Because what would happen if you put in 0 for a right there?
It would just become b equals 0.
Yeah, now you just have that. You don't really have an equation in x anymore. You just wipe the x out. Right? Same thing when we get to quadratics. The coefficient of the quadratic term can't be 0, because if it is, you just wiped out the squared term. Okay, so you don't want to wipe out the linear term in a linear equation. Then it's not linear. It's not a linear equation anymore. All right, so let's solve that. Okay, so in Algebra 1, that'd probably be like a 4th or a 5th lesson in solving equations. But we should be able to just jump right into that. All right. So how about Peregrine? What would be my first step here?
Distributing.
Yeah, what are you going to distribute? We'll start with the first part.
So multiply 2x plus 3 by 2.
Can you say that again?
So multiply 2x minus 3 plus times 2.
Yeah, so you're going to distribute that too. And Sam, what are you going to distribute in the next part?
The 3.
Yep. So we'll distribute that. And for now, that 5x plus 2 is just going to stay where it is. All right, so Chris, can you tell me on the left side, when you do all that distributing, what you get?
You're going to get 4x minus 6 plus 3x plus 3.
Okay, so we've got that. How about, Vinny, what can I do on the left side now?
You combine like terms.
Yep. So can you combine all my like terms for me?
7x
Okay, so it takes care of that and that.
minus 3.
Yep, good. All right, so we've done the distributive property. We combine like terms. We got a few options here. Piper, what's one thing I could do next?
You bring the x's all onto one side.
Okay, and can you tell, there's a couple ways I can do it. Can you tell me one way to do it?
Subtraction.
Okay, subtracting
5x from both sides.
Okay, so she's gonna move all the x's to the left. I think that's a good idea here. So minus 5x from each side, and you get that. How about, Adri, what would I do next?
I would add 3 to both sides and then
Yep.
just add 2x.
And my last step, divide by 2, and x equals 5x. Alright, so again, not really teaching you here how to solve linear equations, I'm more just reviewing it, since I want to really get to quadratics, which is a little bit more algebra, late algebra 1 stuff. Okay. Got any questions on that? Okay. Alright, absolute value equation. Even though it's algebra 1, a lot of people forget how to do it. When you have an absolute value equation, you have to split it into 2 problems. But you want to make sure that the absolute value expression is by itself. And I'll show you what I mean by that. I think I have an example right here. That's a problem where the absolute value is isolated. Here's one where it isn't. Okay. By isolated, I mean that there's nothing else outside the bars on the same side. Okay. If there is, you need to move it to the other side. Like in this case, how would you move that 3 to the other side? Divide by 3. Now what if you had that? Now you'd subtract the 3 and then go from there. Okay. The problem I give you though, you're not going to have to worry about that first step. Alright, so split it into 2 equations after you've isolated the absolute value. The first equation you write down is exactly the same as the original problem. You just take the bars out. That's all you do. Write down the original problem, just erase the bars. Now, second equation is similar, but you got to do one extra thing. Write down the original problem, get rid of the bars, just like you did before, but also change the sign of the number on the other side. Okay, because it's an absolute value. So if I said something like this, there are 2 answers to that problem. What's inside here could come out to 4, and that would be a correct value for x. Or what's inside there could come out to -4, and that would also be a correct value for x. So 2 and -2 are the answers to that problem. Because once you take the absolute value of it, either way, it would come out to 4. Okay, so what's inside the bars equals what was originally on the right, or what's inside the bars equals the opposite of what was on the right. That's what I mean by negate, just means change the sign of the number on the other side. Okay, so let's try an example. All right, so first question, Pat, is the absolute value by itself in that problem?
Yeah.
Yep, so then we're ready to split it. I usually do something like this. Can somebody give me one of the equations I'm going to have to solve?
2x plus 3 is 5.
Yep. Either what's inside the bars comes out to 5, or what's inside the bars could come out to -5. Yep. Either way, they're both solutions. Okay, so when we solve the one on the right, what do we get? X equals 1. And when we solve the one on, that's the left. I can do calculus, but I don't know left and right. So, what do you get on the right side? -4 minus, yep. And there's your 2 answers. So it really, solving an absolute value problem just comes down to solving a linear equation. Actually, 2 of them. So any questions if you had something like this? How you do a problem like that? You just minus the 2 first. And then x plus 3 equals 8, x plus 3 equals -8. Yep.
So you move the 2 to the other side?
Yeah.
Okay.
Yep. Now, how about this problem?
No solution.
No solution. Some people say, well, they just start solving it, and they say, okay, he said put the 2 on the other side, so I'll go like this. And then they split it into 2 problems, and they say, okay, x plus 3 equals negative 12, x plus 3 equals positive 12. And then they keep going, and they say x equals negative 15, x equals 9. Both those answers are wrong. Try one of them. Check it. Plug 9 back in. What's 9 plus 3? 12. And what's the absolute value of 12? Not negative 12. So, anytime an absolute value is equal to a negative, pay attention to that. You can't ever have an absolute value equal to a negative. That doesn't work. Okay? Absolute value of anything will always be positive. But that doesn't mean if this number is negative, it's always a no solution. This one is no solution. What about this? How come that would... That one I would say you can solve it. Right, because now the first step here is to divide by negative 2, which is going to give you x plus 3 equals 6. Now you're fine. Okay? So be careful about having a negative on the other side. Okay? If your absolute value is by itself and you have a negative, that's a problem. If the absolute value isn't by itself and you have a negative, maybe you won't have a negative when you're done. Try moving it over and see what happens. If you still do, then you can't solve it. Okay, so mixture problems. So mixture problems, basically, they always give you something like this. They give you 2 solutions. Right? And they say, well, maybe this solution is a 10% strength, this one is a 20% strength. They want you to mix the 2 together to make a 13% strength. And they want you to mix enough to have 50 gallons. So you have to take a certain amount of one, a certain amount of the other, and you mix them together to make something that they tell you. And they'll always tell you 2 things: how much they want and what strength solution they want. It obviously has to be in the middle of the 2. If you have a 10% and a 20% strength, you can't mix them together to make a 30% strength because you don't have one that's not as diluted. Okay? So one equation that we usually end up setting up is the amount of solution 1 plus the amount of solution 2 that you mix together equals the total amount that they want you to make. Okay, this is the equation for the total amount. The next equation is an equation for the concentration. So concentration times amount, that's the percentage of stuff that you're interested in. So like let's say, just to use simple numbers, I had 100 liters and 20% of it was rubbing alcohol. Well, if I had 100 liters of stuff in front of me and 20% of it was rubbing alcohol, then that means 20 liters is rubbing alcohol. Right? So you're setting up an equation for how many liters or gallons of like chemical you have, right? Just the stuff that you're interested in. And it's usually like rubbing alcohol, or that seems to be what they usually use. Okay. So you have a certain amount of, we'll just say rubbing alcohol in solution 1, plus a certain amount of rubbing alcohol in solution 2, and then a certain amount of rubbing alcohol in the total. Now what's all the other stuff if it's not the alcohol? Maybe it's just diluted with water or something like that. But those are the 2 equations we usually set up. Now, if you don't want to set up 2 equations, you can kind of do like substitution in your head. So like, if you said to me, all right, you want to mix 2 solutions together and get 20 liters. Well, if I had a total of 20 liters, that was my total. And then solution 1, I used X liters. How much would that leave for solution 2? 20 minus X. So all that this first equation is doing is basically giving you a formula for the other amount, which is the total minus one of the variables. But you don't have to do the substitution in your head like that. We can write it out. Okay, so we have two solutions, a 10% and a 25%. I want to mix them together to end up with a 15%. I'm sorry, 12%. And I want 15 liters. So just by kind of looking at it, which solution are we definitely going to use more of? Yeah, the concentration is a lot closer to A. We just need a little bit of B poured in to bring the solution strength up a little bit. We're definitely going to have more of it. Okay. So let's start with our first equation. Amount 1 plus amount 2 equals the total. Let's call this one solution A and B. So how would I set up that first equation using the variables A and B equals, and then I want my total on the other side. Yep.
Would be 15 equals A plus 15 minus A.
Yeah, you can do it for now. Let's just do it even simple. We'll just do it like that. But yes, if you add up how much from the first solution and the second solution, it's going to total 15. Now the next one is concentration times amount plus concentration times amount, concentration times amount. So let's start with A. What is the concentration of solution A? 10%. And we always want to write it as a decimal anytime you use a percent in an equation. So what is that? 0.1. Concentration times amount. So that tells you how much of solution A is actually the rubbing alcohol, or whatever the solution is. Plus, what's the concentration of solution B? 0.25. And how much of solution B do we use? For now, we'll just write it B. We can change that to something in a second. And what is the final concentration they want? 12. And what is the final amount they want? 15. So usually in one of these problems, the right-hand side is a number. You can just do out. So we're going to have 0.1A plus 0.25B equals 0.12 times 15, 1.8. Now we can do substitution for either A or B using the top equation. Let's substitute for B. Using the top equation, what can you substitute in for B? Yeah.
15 minus A.
Yep, it's just 15 minus A. It's exactly like the kind of thing we did with the two investments. You put X in one, 20,000 minus X was the other. But now you've got an equation with all A's. We'll just distribute, combine like terms, and see what we do. All right, so 0.1A plus 0.25 times 15. Let's see, that's just a quarter of 15, so divide by 4. 3.75. Hey, what's 0.1A minus 0.25A?
0.15A.
Yep. And we're going to bring the 3.75 to the other side, so 1.8. I mean, from here, we're just solving the equation. Okay? I think the hardest part is setting the two equations up, but I've given you guys a template for how to do it. So negative 1.95. And last step, divide by negative 0.15. So that's good that we have a negative over a negative, because you should end up with a positive amount. So 1.95. Does anyone know what it comes out to?
A is 13.
Yeah, you start. Okay. So A is 13 liters. So that means B is how much? Got to be 2. Because A plus B had to equal 15. So if you mix 13 liters of A with 2 liters of B, you'll end up with exactly 15 liters and exactly a 12% strength. Okay, so just an application of solving linear equations. System. Any questions on that? Okay. So, quadratics. So this will be the last thing that we look at. So quadratic equations are usually in the form ax squared plus bx plus c equals 0. A, b, and c can be any number you want, except a can't be 0. I already explained why, because it wipes out your quadratic if it is. And then you just have a linear equation. So what's one way to solve a quadratic equation? Yep.
Graph it.
Okay, so graphing is a solution you can always use for anything, really. You can graph it and see where it crosses or where it hits the x-axis, stuff like that. What else besides graphing, if you want to do it algebraically? Factoring, sometimes that's an option. If the a, b, and c are nice numbers. What if they're not? What's another option? Yep. Quadratic formula. And does anybody remember actually there's one more option. We did this a little bit last week. Yeah?
Find the zeros.
So that's with the graphing. We did finding zeros, you can use any of the methods, but there's one other algebraic method besides quadratic formula. It's 3 words. Yeah.
Complete the square.
Yeah, completing the square. So let's try one where you can factor it. That's the easiest type of quadratic because it's the quickest. Okay, so factoring, that'd be something, now we're kind of in like the second half of Algebra 1, but still in Algebra 1 stuff. What's the first thing you'd have to write down when you want to factor? This is more just like something visual. You don't even do any calculations yet. Yeah.
2 sets of parentheses.
Yeah, put your 2 sets of parentheses. All right. And now you're looking for 2 first terms that multiply together to give you what? To give you what? 2x squared, yeah. So what would be the 2 things you multiply together to get 2x squared? Yep,
2x.
good. 2x and x. Now, let's look at our signs. Positive linear term, negative constant. So what does that mean my signs are going to be down here? What is it?
Plus minus.
Yeah. So as Armin just said, you're going to multiply 2 numbers together that give you a negative. Only way to make that happen is one of each. Now, it could be plus minus, it could be minus plus. If we're wrong, we'll have to switch it. Now, 2 numbers that multiply to give me 3. 3 and 1. Okay? I'm going to try it as 1 and 3. Okay, let's check it and see. 2x times x, is that 2x squared?
Yes.
2x times negative 3, that's a negative 6. 1 times x is plus 1. Is that what I wanted?
No.
No, it's close. It's negative 5. I wanted positive 5. So what's the fix? Switch the signs. Don't switch the numbers. If you switch the numbers, then you're going to mess up the number. The sign was messed up, so switch the signs. Okay, now we get 2 times 3 is 6, negative x. Good. Okay, so that's the hard part. Now what do I do? Yeah. If you're going to multiply 2 things together and get 0, that means either this equals 0, which means this, or this equals 0, So this is a parabola that if you drew it, it would cross the x-axis. Okay. Any questions on that? All right. So factoring, pretty quick, as long as your numbers are reasonable. Like if these numbers are huge, factoring can be kind of hard. And also, if you just pick 3 random numbers for A, B, and C, probably not going to work. So when it doesn't work nicely, you could still graph it. But what's the problem with graphing? The kind of answer that it gives you on the calculator. Compared to what we're about to do. What's the difference between solving it algebraically and the way you can write the answer versus the way the calculator gives it to you? Yeah?
On my calculator, it will show not the exact version compared to what we do here.
Yeah, so,
Like estimation.
right. So the calculator is going to give you an approximate answer. Quadratic formula gives you the exact answer as long as you don't round it. Like 3 plus or minus square root of 7 over 9. Okay, something like that. All right. So before we can use the quadratic formula, which hopefully we know, I want to see where it comes from. So what was the other way you can solve an equation besides factoring the quadratic formula? So we're going to complete the square with that. Okay? It's a little different to do because you don't have any numbers. Okay? It's all letters, but the steps are exactly the same. Okay? Does anybody remember what the first thing we did when we had to complete the square was? Yeah, Adrian?
You had to like make sure that the B and C were like squares, like so like 16.
It's something we have to do first. We gotta make sure we do something. So the first step was to make sure it's equal to 0. So yeah, it's equal to 0. So now this might be the second step in your notes. Yep.
Put the constant on the other side.
Put the constant on the other side. Okay, so far not too bad. It gets a little worse. But we got the constant on the other side. Now, what's the next thing? After you put the constant on the other side, you have to make sure that what?
You have to make x squared has a coefficient more than 1.
I like the fact about it's something with the coefficient of x squared, but what does the coefficient of x squared have to be? 1. Yes. So the way to get rid of this a, and you're going to have to do it everywhere, would be to do what? Divide by a. Of course, we're assuming a is not 0, because if it was, that would cause catastrophic problems. So, now the a's are gone, I'm going to rewrite that. X squared plus b over ax equals negative c over a. Actually, I'm going to give myself a little space here. Now, the next step is to complete the square. Does anybody remember you use that and you have to do 2 things to it? Yep.
Half it and
Let me do half of it. So that's half of it.
and square it.
And square it. That's what you add to both sides to complete the square. Doesn't look as nice because a and b aren't numbers. But I took half of this number and squared it. And I'm adding it on both sides. So plus b over 2a squared. Yes, I'm going to do that out very soon. Plus b over 2a squared. Okay. Now, this is probably the trickiest part. You need to factor the left-hand side. Well, we know the first terms are going to be x and x. And they have to factor into 2 things that are the same. So anyone think in the signs it's definitely going to be a plus and a plus? Because the signs up here are plus and plus. Anyone tell me two things you can multiply together that are the same to get b over 2a squared? Yeah, b over 2a. b over 2a. b over 2a. Let's check it. X squared. Now the middle, that's x times b over 2a, x times b over 2a. You have two of those, right? So I'm just checking it. It would be plus 2 of the, how can I write this nicely? b over 2a x. Well, if you multiply by 2, that's a times 2, that's a divided by 2. b over ax, b over ax. That's exactly what I had right there. And then b over 2a times b over 2a is b over 2a to the second power. We haven't even done that out yet. All right, so yes, we factored it correctly. Now the right-hand side's, we got to start doing this out at some point. So let's square that. What do you get if you square what's in the top? b squared. So maybe you're starting to see some things from the quadratic formula. And what about in the bottom?
4a squared.
4a squared. All right. Let's see. Let's factor that. So that's x plus b over 2a to the second power. Now, to put those fractions together on the other side, what would I need to have in order to add those together? Same denominator. What could you multiply this by in the bottom to make it the same as the other one? 4a. 4a, 4a. Anybody recognize that? Minus 4ac? Right, that's part of the quadratic formula, so it's starting with negative 4ac, b squared plus or minus. It's coming together a little bit. So let's write what we got now. Negative 4ac plus b squared. And it's all over 4a squared now. Now, we're going to write that as b squared minus 4ac. That's how you normally write it. I'll do that in the next step. So my goal is to get that by itself. I need to deal with this. How do you get rid of squaring? Square root. So you'd have this equals, now I'm going to do two things here. I'm going to write this as b squared minus 4ac. Keep the bottom the same. Take the square root of what's on the left. That and that cancel. Take the square root of what's on the right. And now we'll simplify what we can there. Okay. If I was doing this like myself, I probably would have simplified during when I wrote that square root. But let's do it now. The top you can't really simplify. The square root of b squared minus 4ac over, what's the square root of 4a squared? 2a. Now when we take a square root, how many answers do you always get? 2. Plus or minus. So the last thing we need to do is put this on the other side. How would you move b over 2a to the other side? Subtract it, and watch what you get. When you subtract it, you get negative b, I guess I can write it like this, over 2a, plus or minus the square root of b squared minus 4ac over 2a. Now I'm not going to write the whole thing again, but that's basically the quadratic formula. Just put one big fraction, because they already have the same denominator. Negative b plus or minus square root of b squared minus 4ac all over 2a. So that's where the quadratic formula comes from. Okay, it's completing the square. So every time you use it, you are really completing the square. You just don't have to think about all the steps because now you have this nice little formula. Okay. Any questions on the idea? A little weird because it's all letters. Sometimes it's harder to follow than numbers, but it's the same process. Okay, So there's your quadratic formula. That part under the root is called the discriminant. And remember, to use that quadratic formula, your equation has to be in standard form. Standard form means it's equal to 0. Okay, let's try this one. Then we have one word problem, and that's it. So, is that equation already in standard form?
Yes.
Yep. What's A?
2.
B?
2.
C?
-1.
Just fill in A, B, and C into the formula. Does anyone want me to go, like, I expect you to know how to do quadratic formula? Does anybody want me to actually do one with numbers? To see it? Okay, so I'll just set it up quick. Negative B plus or minus the square root of B squared. That's 4. Minus 4A. What's C? -1. All over 2A. And simplify whatever you can. You're going to have a -4 and a -1. That's going to turn into, what's it going to do to the negatives? Cancels them out. What's under the square root? $12. Is that simplified?
2 times the square root of 3.
So yep, you got to simplify that square root of 12. Exactly as Piper just said, 2 times the square root of 3. And now what number can you divide out everywhere? 2. That's what I'd be looking for the answer. Okay? So you got to reduce as much as you can. I'm not going to go through this one. I want to go to the word problem, which is the last one. What would you have to do first here, though? Yeah, get it into standard. Don't say A is 3 or B is, it's all out of order. Okay, so you got to make sure you get it in standard form first. Okay, so last question. So we've got a piece of cardboard or whatever it says. Yeah, cardboard. And you're going to cut a square out of each corner so that basically you fold the sides up and make a tray. Okay. It tells you that you're going to cut squares out of each corner that are 5 inches by 5 inches. L and W represent the length and the width of the original piece of cardboard that you're folding. So the cardboard is folded along the dotted lines to make it's more like a tray. There's no top on it. Okay, and they tell me a couple things. The length is twice the width, and the volume is 2,040 cubic inches. Find the dimensions of the cardboard. All right, so what shape are we basically making when you fold up those sides from geometry? It's a rectangular prism. Okay, it's a rectangular prism. What's the formula for the volume of a rectangular prism?
Length times width times height.
So length times width times height. Now, what's my volume here? They tell me that. Okay, my length, well, I don't really know my length. Okay, so just call it L. Unless, do they give me anything? Well, no.
2W.
Yeah, the length is twice the width. So this formula is going to have everything in terms of W. So my length, okay. What's my width?
W.
And what's my height?
5.
Yeah, when you fold it up, it's 5. Okay. Any, let's see. length is twice width. Now, yeah, one thing we've got to be a little bit careful about is the 5 is okay. Now, that volume, does that represent the volume of the original, like, piece of cardboard, or after you fold it into a tray?
After it's transferred.
Right. So this length and width is after you made it into a tray,
Oh, so it's minus 5.
right? So we got to be a little bit careful. This fact that L is 2W, I think that's still something we can use. But look at your length here. Once you fold it into a tray, you've got that part. That's all that's left. So originally it was L. Now how much shorter is it on each side?
10.
So minus 10, right? Once you fold it up, this is going to be the new length of your rectangular prism. It's the original length minus 10. Now let's look at the new width. This is going to be the new width once you fold it up. So what's that going to be? That's W minus 10. Now we're perfect. And the height is still 5. Okay? So I'm going to stop with that, but what you do is now you FOIL this out, and it would be a quadratic equation. Okay? But yeah, be careful, because I get tripped up by that too. The volume is the length and width once you make it into a rectangular prism, not the original length and width of the cardboard. It gets a little smaller when you fold the sides. Okay? But we can finish that tomorrow if we need to. Okay, so the homework on page 88, that's a break-even problem. The whole thing, 35 to 39. And then on page 96, that's on solving linear and quadratic equations. Okay. We'll take a look at that tomorrow. And then tomorrow, we're just going to focus on section 2.4.